this video, I'm going to do course schedule 1, course schedule 2. First, we start with 207. There are total number of courses you have taken. Label from 0 to number of courses minus 1. We're given an array of prerequisites. The prerequisite I equals to AI, BI indicates that you must take course B first if you want to take course A. Okay. Must take course B first in order to take course A. For example, the pair 0, 1 indicates that to take course 0, you have to first take course 1. Okay. Return true if you can finish all the course. Otherwise, return false. Okay, let's see an example. Input or 2 courses prerequisite is okay. This is true because there are totally 2 courses to take, and to take course 1, you should take course 0, so that it's possible. And also number of courses to prerequisite 1, 2, 1, 0, 0, 1, 4. So there are total 2 courses to take. Take course 1, you have to finish course 0. And to take course 0, you have to also take course 1. So it's impossible. And the number of courses, let's see the constraint. The number of courses should be 0 to 2,000. And prerequisites length is 0 to 5,000. And prerequisite I length is equal to 2. A, B is within the number. Okay, A and B, AI, BI, larger or equal to 0, and smaller than number of courses. And all pairs prerequisites are unique. Okay. So for this problem, since we are going to get the we have a prerequisite to take a course, so I will think about using topological sort for this problem. The reason is that because there are dependencies between different nodes, and we are going to find whether there's a legal order. So I will start to model this problem. In this case, course B depends. In this case, course A depends on. In order to take course A, you have to take course B, right? So in this case, the course A depends on course B. So we are going to find an order to make sure that the starting point always be ordered earlier than the ending points. So I'll use Kahn's algorithm, the BFS based algorithm, to do this. I'll first create a graph and get an indegree node to see how many integrees is pointing to the current course, and then I'll use BFS. And whenever I finish one course, I'll decrease the integrate. That means okay, this prerequisite finished, and until all the prerequisites finish, we put it on the queue, and we start from there. And at last, when we found we have processed every node, and the number of nodes is exactly the same as the number of courses, that means okay, we can finish it. If not, that means okay, we cannot finish it because there's something, the indegree record can somehow never decrease to 0. So can I start coding? So we start with getting the graph. I'm going to use a hash map for the graph. I is the course, and the value is a list of courses that can be unlocked after you take course I. So I start constructing this. At the same time, I'm also constructing the integrees. So the index is the course, and the element is how many prerequisites. Okay, so we iterate the prerequisites. Remember, A is the course, and B is a prerequisite. This have to take course B. Okay, so no problem. In this case, we just started construct these two. Whenever we see a course, we just update its prerequisite count. At the same time, we update the graph prerequisite. When that means finish prerequisite, unlock a new course. Okay, in this case, we have finished the initial setup. We also wanted to record how many nodes we have processed. Start with 0, and we construct the queue. So we start with saying, is there anything that doesn't need any prerequisite? If there is, we are going to just put it into the queue. So in order to do this, we just go through the indegree. Equals 0, that means, okay, currently no prerequisite required. Just, okay, add it. Just add this course into the queue. Awesome. Now we start from this. Of course, it's possible we cannot find anything here. We cannot find anything that does not need prerequisite, which makes it impossible to finish. So what we are going to return is whether complete is equal to number of courses. Okay. If it equals, yeah, finish. Not finish. Let's see what's the current course. Top left, that's the course you're going to take. Be taken. Okay, once it's taken, this is a processed course. We just try to see whose prerequisite is cleared. Let's see, unlocked course. Let's call it unlocked course. I mean, in the graph, right? In the graph, the just completed current course, we got a list of unlocked course, and we wanted to just update it. And once we found, okay, it's cleared. That means, okay, we are going to just it's clear. That means we need to that means, okay, ready to take, put it into the queue, ready to take. Okay, let me think. Here, everything looks good. Everything looks good. So far, so good. That's it. I'll just start iterating everything. There. What's wrong with this? Number of courses. Okay, typo. Integrees. Oh, really need to care. Number of courses. Let's see what's wrong with this. This should be 0 once it is clear. Okay, so this time it works. Let's analyze the time complexity and space complexity for the number of courses. So let's assume V is the number of courses and E is the prerequisites, is the dependencies. We call it the length of the prerequisites. Okay. So while we are building the graph, we go through every dependencies. And also in the BFS, we, for every courses, at least get, so the worst case is get into the queue and get out of the queue. And also in the indegree part, we also will go through each dependency which is OE. So the total time complexity is V plus E, and the space complexity is V plus E as well, because in the graph, this adjacency list, we store every edge. And in our integrees, also Q, we need to store all the vertices. So the space complexity is V plus E. Okay, we will do the next problem in next video.